Hey guys. So before we just jump into the notes right away, I wanted to make sure that you guys had a chance to practice graphing a piecewise function. The in-class group got a chance on a warm-up to practice it. We went over it. It's going to be on your quiz. You're going to have to know how to graph it. So I wanted to give you an opportunity. So before we jump into the notes, if you do me a favor, and this will help you too, if you pause this and graph this, and see how you do with it, and then that way if you get it right, you're in good shape, and if not, this is kind of another chance to see a piecewise function graphed. So pause it, when you finish it, unpause it, and you'll see me work through it. Okay, so again, I'm going to kind of go through it fairly quickly just so you can check your answer. The first piece is 2x plus 2, so my y-intercept is 2. My slope is 2, so up 2 over 1. I can go down 2 left 1. Especially with piecewise functions, I like to put a few more points on the graph. And then draw my whole line. And then remember, I only want this line for where x is less than or equal to negative 1. I don't want this whole line. I have to erase part of it. So I go to where x is negative 1, right here. And then I would have to go up or down to wherever the graph is. In this case, it's right here. But, if the graph was up here somewhere, I would then have to go up to where the graph is when x is negative 1. And I only want this line for x values less than this. So I want the left part of the line, not the right part. So I'm going to erase. And then remember, if you are graphing and your piece starts at a certain point, you either have to put an open circle or a closed circle. And here's where you would need to be careful. This is equal to, so it is a closed circle, but had this just said less than, you would have to erase this closed circle and draw an open circle instead. In fact, I wish I would have made that an open circle thinking about it now. But that's the first piece. The next piece is I want to graph y equals 2, the whole line, y equals 2. And then I only want it for x values between negative 1 and 3. So negative 1 and 3 are here. And so I only want it between my pencil and my pen. So I'm going to erase everything outside of my pencil and pen. So I'm going to erase all this stuff. I'm going to erase all this stuff. So it's just everything in between. But again, I have a segment here, so I have to bookend it. I have to put a cap on it. And notice both of these are just less than, not equal to. So I would actually put open circles on the end of both of those. Remember, they don't have to connect. This is perfect. And then my last piece is y equals negative x plus 1. So the y-intercept is positive 1. The slope is negative 1. So down 1, right 1. Down 1, right 1. It's this whole line. But then I want to erase part of this line. I only want this line for x is greater than or equal to 3. So when x is 3 here, I want it to start here, which means I only want this side down here. I want it for x values down here, so erase everything to the left of this. All this stuff goes away. So notice it starts right when x is 3, right here. It's a closed circle because it's equal to, and continues to the right. And there's my piecewise function. And in the end, you should be able to take a step back and make sure it is a function. Make sure it passes the vertical line test. And this conversation always comes up. Students are like, well, you have two spots right on top of each other. Well, that's why we have an open circle. This is actually not part of the graph. It's just kind of like a boundary. This is the point that would be included. So it does pass the vertical line test. So hopefully you tried it. If you didn't get it right, hopefully that explanation made sense. And if you have any questions on those, make sure you ask. All right, we are going to jump over to the notes. Fairly quick lesson today. It's operations with functions. We talked about functions, but now it's, okay, how do you add them, subtract them, multiply them, divide them, yada, yada. And so some of this stuff is going to be old news, but just new notation. So we have two functions here, and this says find f plus g of x. F plus g of x. First of all, this doesn't mean to multiply by x. This just means that you're going to keep your answer in terms of x. Like another way you can write this, and I have students do this every year, another way you can think about this is doing f of x plus g of x. Like that means the same thing. Basically, you're just adding these two functions together, which we've already worked on in chapter P. So we would do 2x minus 3 plus x squared minus 1. And then we just combine like terms and put it in standard form. So x squared plus 2x minus 4. If it would be factorable, you do not need to factor. That's not part of the assessment. I'm not asking you to do that. So if this was able to be factored, you wouldn't have to. It wouldn't be wrong, but you can leave it like this and not worry about factoring. All right, f minus g of x. Well, now we're subtracting f minus g. So it would be 2x minus 3 minus x squared minus 1. Notice I put parentheses on this one. I really should have put parentheses on the first one. But when you're adding, the parentheses don't really do anything. Like the parentheses may have well not even be there. But when you're subtracting, the parentheses matter because you're subtracting the entire second function, meaning the minus sign gets distributed inside of here. So we can drop the first set of parentheses. Those aren't doing anything. And then distribute the negative. Negative x squared plus 1. And then just combine like terms. Negative x squared goes first. 2x goes second. Negative 3 plus 1 is negative 2. And we're done. So notice I'm not multiplying by x. That's one of the bigger mistakes students make with this. They'll do like f minus g and then multiply everything by x. And that's not what's happening here. The next one is multiplication. F times g of x. So now we're just going to put our two functions next to each other and FOIL it out. So again, none of this is new. It's just new notation. So now I have to actually multiply these two functions together. So distribute. So that's going to be 2x cubed minus 2x minus 3x squared and then plus 3. And then I like to put it in standard form. None of these combine, so I'm just going to write it in order. And I'm done. So we can add functions, we can subtract them, we can multiply them, and we can divide them. To divide them, you just put them on top of each other. Now, that seems like the easiest one until you realize, like, if you get here and it can be simplified, I'll want you to simplify it. Like, if you can factor and cancel, going back to chapter P, I would want you to do that. Well, x squared minus 1 does factor. It's a difference of squares, but then nothing cancels. So you can just leave your answer just like this. Okay, so I want you to notice that the first four were all in terms of x. It was like of x, of x, of x, of x. This next one has a number there. It says find g minus f of 3. What this means is you're going to be plugging 3 into your functions. Like your answer won't have x left over. So you can think about, just like up here, you could think about it as f of x plus g of x. Well, this you can think of as g of 3 minus f of 3. That's really what this is asking you to do. G of 3 minus f of 3. So find your two numbers and then subtract them. So g of 3 means I go to the g function and I put 3 in for x. So 9 minus 1 is 8. So g of 3 is 8. F of 3 means plug 3 into the f function. So 6 minus 3 is 3. So 5. So notice all the other ones had x's left over, but this one, since there's a number there, be careful, that means plug 3 in the end. Okay, the next is kind of new and kind of a big, important concept in Algebra 2, and it comes up throughout your math classes, and it's this idea of what's called composite functions. A composite function is when you take one function and that becomes your input for the other function. Now that sounds confusing, but let me explain. Hang on, I got a sneeze coming. Oh. Bless you. Oh, thank you. There's no one in the room. It's just me. Okay. So two different notations, but they mean the same exact thing. Sometimes you might see this little circle right here. This doesn't mean fog. This is read as f of g of x. F of g of x. Now, if it were me, I would write it in this notation instead, right here. So I want you to notice how this is f of g of x. Anytime I see this little composite notation, I would write it like this one. And so now you can actually see g of x is your input. It's like f of g of x. What this means is we're going to take the g function. In this case, 2x is the g function. That becomes our input in for x in the f function. Again, that sounds confusing, but what that means is we are going to take this x right here, and instead of putting a number in like 3 or whatever, we're going to replace this x with 2x instead. This function becomes the input for the other function. So we always input the second function into the first function. So we would plug g into f. Here we would plug g into f. And so the way this looks, we're going to rewrite the f function, but where the x is, we're going to put 2x instead. So it would be like 3, and then where that x is, we would replace it with 2x squared plus 2. So I know all that sounds confusing. I get that. But look at all we did. We just took the g function, and we plugged it in for x in the other function. Just replace the x. And now we just have to do a little algebra. So square the 2x. This is a case where we can distribute because there's no plus or minus signs. So it'd be like 3 times, this would become 4x squared. And then that would be 12x squared. But again, just understanding, we plug the second function in for x in the first function. And you'll get some practice on your assignment too. The next one says g of f of 4. I hate how this notation looks, so I would rewrite it like this notation here. So this would be like g of f of 4. So I rewrite it. It means the same thing, but this is a lot easier to understand. We just work from the inside out. What this means is find f of 4. Work from the inside out. Figure out what f of 4 is. So if I plug 4 into the f function right here, I would get 4 squared is 16 times 3 is 48 plus 2 is 50. So f of 4 is 50. That's not the answer, but that means that now I can plug 50 where f of 4 is. Notice f of 4 is 50. I don't write f of 50. F of 4 just becomes 50. Now I just need to figure out what's g of 50, and whatever that is, that's my answer. G of 50, well now I'll plug 50 into the g function. 2 times 50 is 100. So again, composite functions mean you're plugging one function in for x in the other function. Last few examples, nothing new, but just instead of having an actual equation, you can get asked the same questions from a table, from a graph, and so I just want to talk a little bit about that. So part A says find g of 1 plus f of 7. So what this means, g of 1, well, this means I go on the g graph right here, and this is just saying when x is 1, what's the y value? That's all this is asking for. When x is 1, what's the output? So I go on the g graph, and when x is 1, my y value is 2. That means that g of 1 is 2. It's the y value when x is 1. That's what's being asked. F of 7, well, notice this is f of x here. This table is f of x. So we're not using the graph, we're using the table. F of 7, well, 7 is the x value. So here. And this is just saying, what's the y value when x is 7? Well, the y value is 3. So f of 7 is 3. 2 plus 3 is 5. The next one kind of goes in the reverse order. This is saying now they're giving you the y value. I have a lot of students that they'll write like x and y. That way it keeps track of what's x, what's y. So this is saying when the y value is 1, what's the x value? This one messes with students. It kind of flips the thinking. So on the y-axis at 1, it's saying at 1, what are the x coordinates here? Like if I go across left and right, what's the x-coordinate of this point? What's the x-coordinate of this point? That's what's being asked. When the y value is 1, where are the x values? So this x value is 2. This x value is negative 2. So I would say x equals 2 and negative 2. So notice on the first one, we were looking for y values. And then on this one, they give the y value, and you're looking for x. And then the last one, a composite function, and we're just going to work from the inside out. Find g of 2 first. G of 2 means go to the g graph, and when x is 2, the y value is 1. That point right there. So g of 2 is 1. I replace g of 2 with 1. Now I'm looking for f of 1. Whatever that is, that's the answer. So on the f table, when x is 1, the y value is 5. So f of 1 is 5. You'll get some practice on your assignment. If you have any questions at all, please email me, and I'll be able to get back to you pretty quickly. Peace.